Welcome back to the UAV Understanding Drone course. Now, after designing the drones, the very first question that comes to our mind is how to control it. There are two ways to control the drone, either remotely or on autopilot. In order to control a drone remotely, you must be able to communicate with it wirelessly. Radio waves are an invisible waveform on the electromagnetic spectrum. Like all things on the electromagnetic spectrum, radio is measured in hertz. Extremely low frequency is anywhere from 3 Hz to 30 Hz, and tremendously high frequency is 300 GHz to 3000 GHz. For radio to work, you must have a transmitter to send the messages and a receiver to get the messages. At a rudimentary level, this is how remotely controlling an aircraft is accomplished. More precisely, your transmitter and receiver need to be tuned to the same frequency. To avoid situations such as your drone being controlled by someone else's remote control, devices use a unique identification code to identify a transmission on one particular radio frequency as a transmission it wants to receive. To do this, transmitters and receivers are paired using an RFID or a radio frequency identification. All information broadcast over RFID is prefixed with an RFID so that the receiver knows that the information it is picking up is for it. Lower frequencies tend to have a much greater range at lower power than higher frequency devices. Lower frequencies also have a greater ability to penetrate dense objects, which is another reason why they are great for remote controlling a drone. However, the lower the frequency, the larger the antenna must be to receive the frequency. Most remote control drones use 900 MHz for transmission. Higher frequencies in the 2.4 GHz range are predominantly used for Wi-Fi. Now, there are two remote control methods, Wi-Fi control and GPS control. Wi-Fi control. Wi-Fi used to only be available on computers, but as the technology evolved, shrunk and grew more intelligent, it was integrated into portable devices like phones and tablets. Now, there are several million products around the world that are Wi-Fi enabled so that they can be remotely accessible. Most drones today are Wi-Fi enabled so that they can broadcast video to a computer, tablet or smartphone. Some drones also use Wi-Fi for remote controlling through a tablet or mobile application. The Parrot AR Drone 2.0 offers high-end interactive controls with their mobile application that runs on an iPhone or iPad. GPS Global positioning technology has shrunk down enough that it is possible to ping satellites for location data from devices as small as a smartphone and your drone. GPS is primarily only used to communicate location back to a mobile app. GPS is also used for pre-programming routes. Once programmed, the drone can be cut loose and it will fly in the sequence to each of the GPS location identified. The autopilot works on this GPS-based waypoint navigation. Waypoint GPS navigation allows a drone to fly on its own with its flying destination or points pre-planned and configured into the drone remote control navigational software. This instructs the drone where to fly, at what height, the speed to fly, and it can also be configured to hover at each waypoint. First of all, we need to know what is a waypoint. Satellite navigational devices function around one premise, and that is they can mark a location anywhere on the earth. The term that we use for that is a waypoint, and the dictionary definition is that it is a reference point in physical space. In simple words, waypoints are physical locations to which the drone will fly. These waypoints determine the path. It is a route and destination planner for your drone. The points are stored electronically rather than on the map as a pen mark. There are three important things we can do with GPS waypoints that take it beyond the realms of the mark of a map. First one, from anywhere around the world, whether that's 20 meters away from here or 50 meters away, 100 kilometers or 1000 kilometers, we can come straight back from a starting point, an exact location in a straight line from anywhere. Second one, waypoints can be transferred onto a computer's digital mapping software. Third one, we can share our waypoints with other people. So when we want the drone to navigate, the first step is to give the position of the waypoints. Then there will be a pattern drawn joining the waypoints. We can vary the altitudes for each waypoint. For example, we can give 50 feet height for waypoint 1 and 100 feet height for waypoint 2. Hence, the drone will fly using autonomous waypoints. These are some of the examples of the patterns. 3 different paths are analyzed. First one is the clockwise square path, the second one is a butterfly path, and the third one is a snaking path. In the first figure, 4 waypoints are placed in a cyclic clockwise manner. Hence it is called the square path. In the second figure, 4 waypoints are arranged in a diagonal pattern. First at the top left, second at the bottom right, third is at the bottom left, and fourth one is top right. And hence, when we join, the wings of a butterfly is obtained. In the third figure, 6 waypoints are arranged. First and second at the top, third and fourth in the middle, fifth and sixth at the bottom. So when we trace, a snake pattern is obtained.